Yeah, thank you for being here. Thanks for sharing your time with me. Unfortunately, my Polish is, my language skills are not good enough to speak Polish, so I can only say Dobry dzień. And the presentation itself will be in English, if it starts. Well, great, here we go. So it's more about the big picture. It's about how we see DDoS attacks. Perhaps if you've read the press, then you've seen Krebs Online has been attacked, lots of gigabits coming in, and it can happen to everyone. But we mostly, if we talk to customers, then we get responses like, wrong button. We will not be attacked. Yeah, doesn't happen to us. We will not be attacked. So let me come back to this first slide. I'm talking about fallacy, and fallacy means it's when you talk about something, but you don't have the reality behind. So you've got the wrong reasoning. And the reasoning is, in this case, it's we will not be attacked, and this is wrong. So we will see lots of attacks coming in, and it happens to everyone. So in this context, there are more wrong assumptions. Something like, well, we will not be attacked because our website is not big enough and it's not popular, so who should attack us? Or something like only big companies having the risk of being attacked. Sometimes you hear, we have never been attacked, so why should it happen to us? And it goes on like no interesting goal, our risk is manageable. But then if you take a closer look, then what happens if you're attacked? It is like somebody plugs out your internet connection. So your servers are online, everything's up and running, it consumes a lot of power, lots of energy, but you're not in the internet. And this is what happens when you get a DDoS attack. And I'm not talking about big DDoS attack, I'm just talking about a DDoS attack. So what we see in the course of time is just taking a picture from 2 years ago. So we've seen some attacks around 100 megabit, you see some are at 10 gigabits, and you see low attacks and high bandwidth attacks. So it's everything in between. The picture doesn't really change, so bandwidth are still the same, but it's a lot more attacks you see. And the medium, so the middle of the attack is at something like 5 gigabits. In other words, it's just a tiny bit above your internet connection. And this is what happens if the attack comes in. It brings down your internet connection. What we see is several collections of people. It might be only one guy, might be several guys, but these guys are looking for your money. So we see a company or people call themselves DD4BC. I like the abbreviation. It says what they are going for. They want to have your bitcoins, and to get this bitcoins, they're going to attack you. So this is pure DD4BC. It's their motto, and they do this. Well, they did until they have got caught something like a year ago. But the next group with the same name is already there. Then there is Armada Collective. From my perspective, the difference between DD4BC and Armada Collective is they've been a bit more professional. If they tell you, we attack you, they attacked. Armada Collective does or does not attack. Anyway, if you are attacked, then you're down. Sometimes it's anonymous, and sometimes it's complex goal-oriented attacks. I like the newest business model, which is called DDoS coins. So somebody is giving out coins, DDoS coins, if you help him to attack somebody else. They've got a measurement for that. So if you're interested in getting DDoS coins, then you can change them later into Bitcoins. They are asked for that, and then, well, it's a business model. We're talking about business. It's not something that happens occasionally or by accident. It's a business. So why should we be attacked? The reason is, well, there might be no reason. What we see is who is attacked: business services, education. Why should you attack a school or a university? No reason for that. Financial services, gaming. Well, there is a reason. Within gaming, if you are a gamer and you're competing against somebody else and you bring down his connection, then it might be you're faster than him. So there might be a reason. Hotel, travel, internet, telecom, and so on. So it goes through everything. These are the organizations that are attacked. On the other side, there are several people who attack you, script kiddies. Well, we found this new tool, we want to try it out. Hacktivists, something like they've seen an advertisement where somebody gets something to eat and then the vegetarian party attacks them because it was meat. And they don't like seeing somebody in an advertisement eating meat. So this company has been attacked for this reason. Hacktivists. You sometimes don't get why they attack you, but they do. Extortionists. This is what we see most. They attack you for a short amount of time, then send in a notice, we've attacked you, and your infrastructure is prone to going down. And we can tell you how you can secure your internet connection. Just pay us some bitcoins, and it's something between 500 and 2,000 euros in bitcoins. Might be ex-employees, competitors, or state-sponsored. For competitors, we have seen pizza delivery services in Germany. Two different big companies, and as soon as one of them had a special price, it went down. And then the other one had a special price and then went down. In the end, nowadays, both of them are our customers and no more attacks. Okay, so you see, even competitors do that to themselves. In other words, there is a hater for everyone. And about DDoS attacks, it's really easy to start these DDoS attacks. If you followed Krebs online security, then he showed up that there are two guys who has set up the back servers for DDoS attacks. So this is the front end. So you see a lot of front end where you just can't connect to that. They offer free, well, they mostly call it stressors. So you can stress your website, or you can stress anybody else's website, but that's not allowed. So you stress your website. Oops, wrong IP. And then it goes down. How does it work? They've got an API call to this service that just went down. And then this backend will do the actual attack. And there's a nice scheme of washing bitcoins in between, so you can pay these attacks by bitcoins and it will be forwarded somehow in the internet. Problem is, in a shared environment like today's cloud or hosting, if one of the other customers is attacked, your server might go down as well, because if the line is flooded, well, the line is flooded. Happened to a company called mail provider. I'll come up with the name later. And they've been attacked, or they have got this extortion letter. Please pay us some bitcoins, otherwise we will bring you down. And then they paid the bitcoins, and then they went down. If you compare this attack, which has been a huge bandwidth attack, with the setup of the extortion letter, then they don't match. So the extortion letter is more like script kiddies, and the attack was very professional. So this script kiddie sent a letter, hey, sorry for that, but it wasn't us bringing you down. So they paid it and eventually got down from somebody else. And so it's, in the end, it's not the question who will be attacked, it's only the question when you will be attacked. Just to go back to this picture, it gets closer. So, okay, accept it. we might get attacked. But we've got our classic security solutions, and they are offering enough protection. We've got everything in place. So we've got an internet pipe, we've got firewall, intrusion protection system, load balancer applications, we are safe. Well, in the end, all these devices are developed for protection of data integrity, for protection of access control, and for confidentiality. I'm still struggling with this word. It does data inspection. Data inspection needs resources. And if you attack these resources, just use tailored attack for that, then these resources will go down. So what happens here is the device is not part of the solution, it's part of the problem. So you might get attacked by somebody tailoring an attack directly to you. Best example, the TCP Christmas tree packet. The Christmas tree packet is a packet where all flags are set. It's the SYN flag, the ACK flag, the push flag, the reset flag. So the load balancer gets this packet and it sees, oh, I have to reset the connection. No, wait, I have to acknowledge, I have to SYN. So it gets confused. And we see a lot of these packets coming in as part of the attack. So it's directly targeted to your load balancer. So there are tailored attacks going directly for your infrastructure. You see, we've put in some numbers, so you see how many attacks are here or there, but these numbers vary per attack. And then, okay, I've got that. We need more bandwidth because attacks are, you just said 5 gigabits, so we go for a 10 gigabit attack. And then we've got this protection on the bandwidth level. Well, it's not really enough. If you check this, you see in 2005, we only have seen attacks in the size of 11 gigabit. And then it slowly went on until 2014. In 2014, we have seen something close to 400. Actually, it's been only 320 gigabits. 2015 has been holidays, no big attacks. And since something like 2 months, the race started over again. So we've seen 2 months ago 360 gigabits of attack, so new record on our platform. Then we have seen from other vendors numbers of 400, 500 gigabits, and now we have seen a 660 gigabit attack from the internet to this customer. We mitigated that and found out the internet has problems. We are fine, but some peering points went down, so some of our partners or the peers of our peers had problems with that. It's the Polish Network Operators Guide, so group. So some operators are here. Who is having more than 1 gigabit of bandwidth in the audience? 1 gigabit and more. 1 gigabit of bandwidth to the internet. Okay, 1, 2, 3. Okay, 10 gigabit and more? 1, 2, 3, great. 4, nice. 50 gigabit. You see, in 2009, you might have survived. So these are the biggest attacks we are seeing. Not everything is like this. Check out the State of the Internet report, and you see the median, and you see what's happening. In fact, even if you are a big internet provider having peering points with other internet providers, then the total capacity might be 100 gigs. But if the attack comes in from this internet provider and you peer with him, then it's mostly, well, it's Ethernet. 1, 10, perhaps 2 of them, 20 gigs. So if the attack comes in, it floods your peering point. So the peering point will be flooded, no more connections, the BGP session will go down, the traffic will take another route, will flood this peering, so you will have service degradation. So even with small attacks, ISPs are running into problems. So what we done is we have decentralized scrubbing centers, so push it out closer to the source and just add more bandwidth. When I started with this company, they told me, oh, we are having 2.3 terabits to the internet. And I said, what? So we've grown to 3 dot something, but if you take a look on the attacks, and we've seen several attacks at the same time, then you see you need a lot of bandwidth. So this is our scrubbing bandwidth, and we try to stay at 3 times the maximum bandwidth we have seen. Sorry for the marketing. I want to stay at what is really happening. So another thing is attack complexity. Well, it's just packet floods. So just to mitigate these DDoS attacks, you don't need an expert. It's easy packets, just get rid of them. They are simple, they are not sophisticated, pure packet floods, easy to spot, easy to block. Well, in reality, it's not true. So we see 97.44%, which is infrastructure layer. That's correct. But there is some application layer DDoS in between. It's only 2.5%, but 2.5% of 4,000 attacks we have seen the last quarter is still a lot. So you see a lot of application layer traffic inside the attack. And some of the attacks have several vectors at the same time. I will cover that later. But even in the infrastructure itself, it might be UDP, it might be TCP, Synax, whatever it is. So it's not so easy. And then in the end, you need somebody concentrating on DDoS. So it might be difficult to jump in here and pay the resources to fight the DDoS attacks. And so the reality here is the DDoS attack can attack bandwidth, so saturating the link, but it can also go for your network elements or your servers, or all of them. So we see multi-vector attacks. Well, some people come up with the idea of outsourcing their websites. It's a good start, because then your web servers have this CDN out, and if somebody attacks your web server, in fact, it will attack the CDN. Well, you have to pay for the bandwidth, but anyway, your server will stay up. If it's something like an infrastructure attack. But we also see layer 7 DDoS attacks. And a CDN is forwarding clever stuff, like he's doing caching, caring for HTTP, but he doesn't look into security of web applications. So what you would like to add would be web application firewall. So a simple CDN delivers the basic protection for static content, but if you've got dynamic content, so you've got a website where you can shop for some things, then it has dynamic content and can be hacked or it can be brought down. So going for a CDN to protect your website is a good start. Please check them wisely if they offer more than just the CDN stuff. I talked about multi-vector attacks. So what we see is single vector attacks in Q2 2015. So most of them have been single vector attacks, 56%, and only several of them have used more than 3 attack vectors. If you compare this to the dates today or to the last quarter we have reports on, then you see 3 vectors is at 12%, 2 vectors 42%. So we see up to between 5 to 8 different vectors. So the amount of single vector attacks is going down. So it gets more complexity, it adds more complexity. Reason I talked a bit about that has been this backend called VDOS, and it provides back-end attacks. So you can just simply by using API calls from your front end add different attack layers. So it's so easy to do that. By the way, if you've got any question in between, happy to answer questions here. So our approach is we check for, we secure the infrastructure. So there is the data center behind, and if somebody attacks the data center, then we've got the infrastructure protection. It gets rid of the packet flood. We have added the application level protection. So I've talked about CDN. The blue part originally has been our CDN, but we have added application security. So we rolled out web application firewalls on all of the connected servers. So every one of these dots where you can connect to have their own web application firewall. And if you bring one of them down, it's always in pairs, the other one takes over. 3 elements if you want to be in the internet: the infrastructure, servers, load balancers, links. This is secured by the infrastructure level protection. Web applications, the blue part. And then if somebody brings down your DNS server, everything's up and running, but you're still unreachable. So this is why we've added the 3rd level. So if you want to do protection for your website or for your customers, think about the 3 levels that you have to secure: the applications, the infrastructure, and the name services. Well, I'm talking about big attacks, 300 gigabit attacks, 500, 600. OVH is talking about the terabit attack. Well, that's really bad. The bigger the attack, the worse it gets. It's still one of the fallacies. It's still wrong, because I've already showed this picture. The median size is 5 gigabit. It is 5 gigabit because the median internet connection is slightly below 5 gigabit. So they start the attack and they bring it up to a point where you go down. They've got quality assurance. So the quality assurance checks if your server is up or down, and if it's still up, they just rise the attack level. So it doesn't matter if you get a 100 gigabit attack or a 200 gigabit attack. Probably one of the reasons why we didn't see these big attacks last year, they more go for effectivity. So instead of having 100 gigabit attack, you can attack 5 people with 20 gigabit, which might be enough. Still, we see them, some dozen attacks are above 100 gigabit. And we see different industrial sectors being attacked. Email provider late last year, online pharmacies early this year, Swiss retailers March of this year. So it's always attack campaigns. By the way, this is the reason why this company has grown, because somebody came up with attacking the financial sectors, and they were happy to pay for protection. And so one of the campaigns more or less started this company, or this part of the company. And as I said, as soon as it reaches your level of bandwidth, then you're gone. So it doesn't matter how big the attack is in reality. And then, well, DDoS, it will just bring me down. So what's the problem? I'm not really relying on that. And the cost of a DDoS attack in the end cannot justify the cost for a security solution. Well, there are some hidden costs behind. Something like operational expenses and indirect costs. So I've talked to a customer and he told me, well, we've been attacked and it went down. It wasn't that bad. We've been unavailable for some time, but we have outsourced our first level support, or second level support, and it's in a call center. So everybody called the call center. The call center has been really happy. They've taken all the calls and have sent in the bill. And then they have looked at the bill and said, for the amount of the bill, we could easily have paid 2 years of your DDoS protection. So there are some hidden costs behind. So if you think about what does a DDoS attack cost, then think about also about revenue loss, SLA compensation. Perhaps you're paying to somebody if you're unavailable. About stock price fluctuation, it's not really easy to measure that. Churn. Customers don't believe in your quality. Excessive emergency costs. Oh, there is an attack. We have to do something, and we have to do it immediately. So this is something that you have to keep in mind. So DDoS attacks should be part of the risk management as the risk can be predicted by statistics. Which time do I have? 2 minutes? Okay, so it looks like you have to download my slides. Not too bad. We've got a recommendation, and I can cover that. So your IT components should be used according to their planned purpose. So firewalls are firewalls, they are not DDoS protection. I've worked some years with Extreme Networks, some years with Juniper Networks, all great stuff, but if you talk about big DDoS attacks, they are not the right tool for that. And securing the availability of the network is just a basic requirement and should not be underestimated. In Germany, we even have a law for that. So if you have crucial, industry, then you have to secure your availability of the networks. Check other connections. So if there is an open IP address that can be attacked, which is not secured, then your complete data center might go down. So take a complete look on that. Check multi-level protection, not only the bandwidth. Volumetric attacks cannot be mitigated locally. Something behind the leased line cannot mitigate something that is flooding the line. And during a DDoS attack, your staff should care for everything else. We have seen smoke screens, lots of packets coming in. So people have been really busy. 1-2 months later, they found out they have been hacked because they didn't realize it because they've been busy with fighting the DDoS attacks. And think about pushing out the mitigation perimeter, which is bring it to your ISP, or even better, bring it to somebody who is even bigger. So I will end with this slide. So this is what we really have seen. It's a time scale. 15 is not the hour, it's the 15th of July. It started on the 14th and it didn't end on the 23rd of July. So the guy attacking was really angry. It ended in August. You see 300 gigabits attack in the beginning, several bigger ones, and different colors mean different mitigation technologies, so we've been really busy. At the same time, they have attacked DNS. Customers stayed up because my colleagues had a lot of work. By the way, at the same time, we fought something like 10 attacks for other customers. So we're doing that at the same time in parallel. So just to give you a picture what we are doing, how we are mitigating DDoS attacks. Thanks for attending this. And if you've got a question, I'm from Akamai. We've got a stand around here. Send in an email to stefan@akamai.com if you need more information. Thank you.